Okay, today we're going to talk about 1.9 trophic levels. So check out the Enduring Understanding, look at the learning objective, you can pause the video, review the essential knowledge, and set up your Cornell notes. So just a reminder that trophic levels, trophic refers to food. Anytime you see the word troph, it means feeding. So an autotroph makes its own food through photosynthesis. A heterotroph it consumes another organism. It is a consumer. It will not make its own energy, but get it from another source. A chemotroph, for example, is like the tube worms that live in the hydrothermal vents on the bottom of the ocean. They're using chemicals to obtain their food sources. Okay, so again, troph means food. Now, in order to talk about trophic levels, we need to understand conservation of matter. This is a law. The law of conservation of matter states that matter is neither created nor destroyed. And to show this, I have right here a little diagram of a chloroplast, which is the organelle where photosynthesis takes place. It is in the plant's leaves. It contains chlorophyll, which is the green pigment, which gives the plants their green colors. This is all review from living environment. But what happens in photosynthesis? You should know this. What comes in? We have carbon dioxide coming in. We have water coming in. This is the actual chemical equation. We have 6 CO2s coming in and 6 H2Os. Now, why is this? Because we need to have 6 carbons in order to make our glucose. The glucose has 6 carbons. So when you're balancing equations like you did in chemistry, the reason you're balancing the equations is to show that we have this conservation of matter. So you have a whole bunch of red dots in here. Well, that's because you got these oxygens and you had all these CO2s. So when you add more of one, these six carbons, you need 6 CO2s. Well, that's a whole bunch of oxygens. Now you need more. Anyway, when you balance out the equation, you'll notice everything matches up. You can pause the video if you want to count all the dots. Do it yourself if you wish. Trust me, I already did that. Okay? Now, when we're talking about laws of thermodynamics, well, what does thermodynamics mean? Well, it means heat. Thermo means heat. Dynamics refers to energy. So dynamite, if something is dynamic, it has energy, it's moving. So thermodynamics refers to heat and energy. So whenever energy transfers, it degrades, which means that less is available for other sources. Now, the first law of thermodynamics, and this is something you just have to know, that energy is neither created nor destroyed. It only changes form. So you can have, for example, I can hold something up here. I don't have anything. I can hold something up here. This has more potential energy than something that is lower down. When this higher material, whatever it is, falls down, the potential energy is created to kinetic energy. When the kinetic energy, when it hits the ground, it may release the kinetic energy again converts back to potential energy. It may lose some in the form of heat. So the second law states that energy degrades when it changes source or changes forms. Okay, and the most degraded form of energy is heat. So a lot of times when it changes from one form of energy to the other, heat is released. And that is something that we have to remember as we are talking about trophic levels. So trophic levels, again, are just feeding relationships. In areas that you have high productivity, you have a lot of available energy, which means that you have more trophic levels. Again, the more photosynthesis that occurs, you're going to have more food webs, more intricate food webs, you're going to have more trophic levels. Now, terrestrial food chains and aquatic food chains, typically terrestrial food chains will have secondary or tertiary consumers. This is the first trophic level, and that is for the producers. These are the autotrophs that are using the sun's energy through photosynthesis to obtain their carbohydrates in the form of glucose. You have a primary consumer, and a lot of times primary is written like 1 with a little degree behind it. Like 1 degree means primary, 2 degrees would be secondary, 3 degrees would be tertiary. A primary consumer, an example of a primary consumer would be an herbivore. In other words, an organism that is a heterotroph that only consumes producers. So these herbivores, an example would be zooplankton in an aquatic food chain or a zebra in a terrestrial food chain. Now the secondary consumers are carnivores because they're eating another consumer. So the secondary consumer is the first carnivore that you will have, and that could be a lion, which is at the top of the food chain in a terrestrial food chain. It could be a fish in an aquatic food chain. And once you go up to tertiary, the 3 with the degree behind it, tertiary consumer, if there is one, there may be a tertiary consumer in a terrestrial food chain, but often you'll see a tertiary consumer in an aquatic food chain. And in this example, it would be a bald eagle. Now there is another layer. You could have a quaternary consumer, and that would be a top predator. In both of these, there is no quaternary consumer. Quaternary just means the 4th level consumer. Now the energy always flows from the bottom to the top, and as you go between each one of these trophic levels, you are losing energy, and that is because of the metabolic processes, which we will talk about in another video. What I would like you to do is practice. Again, you're going to see this food web. So other than showing feeding relationships, describe what is indicated by the direction of the arrows in this diagram. So take a moment to formulate your response. I thank you very much for your attention. I hope this video was informative. I will see you soon.